So when graphing equations of lines, we're typically going to be working with a linear equation. A linear equation is an equation whose graph is a line. It may have one or two variables with real number coefficients being added or subtracted with no variable having an exponent other than 1. So in that top line there, we have all examples of possible linear equations. As you can tell, there are many different variables, yet they all have an exponent of 1. Okay, in these non-examples, there is just a couple things to look at. In the first example, we can take a look at this fraction. In this fraction, the variables are being divided, which can't happen in a linear equation. So the reason this is not linear is variables are not added or subtracted. In my second example, I have x squared plus y equals 5. The issue is my exponent, and that would be the same with my last equation as well. So the exponent is not 1 in both of those equations. So those are just a couple things to take a look at. So this is how we're going to apply this concept. So to graph using x and y intercepts, we'll be given a linear equation. This one's in standard form. So to find the x-intercept, that means that we're going to substitute in a 0 for y and solve the equation for x. That will act as our x-intercept. So doing so, I would have 2x minus 3 times 0 equals negative 6. And now I'm going to simplify. 2x minus 0 equals negative 6. That's the same as just saying 2x equals negative 6. Then I'll divide both sides by 2, leaving me with x equals negative 3. So that means that my x-intercept is going to be negative 3 and 0. And I can go ahead and make that point on my graph. Same exact concept with the y-intercept, except this time we are going to substitute a 0 in for x. So this gives me 2 times 0 minus 3y equals negative 6. Once again, this would simplify to 3y equals negative 6, which is y equals positive 2. So my y-intercept for this case would be 0, positive 2. Now I can go ahead and graph that point as well. Once you've graphed your x and y intercepts, you can go ahead, connect the points to make your line. Make sure you add arrows on both ends of your lines. Okay, the next way we'll graph is graphing using slope-intercept form. So when we're graphing in slope-intercept form, we're first going to solve the equation for y. So this equation here, solve this for y, we need to multiply by the reciprocal. Well, the reciprocal of negative 1/4 is just negative 4. By doing that, we are going to get y equals negative 4 halves x minus 4, which could simplify to be y equals negative 2x minus 4. That's my equation for y. Once you solve for slope-intercept form, then we'll plot the y-intercept. Remember, the y-intercept is the number that's being added or subtracted to our variable. So in this case, my y-intercept would be 0, negative 4, and I can go ahead and graph that. Next, we are going to plot the slope. Remember, your slope is your coefficient on your x variable. So in this case, my slope going to be -2. Or if you like to think about this as rise over run, -2/1. So I'm going to go down 2 over 1. Or up 2, left 1. Once you've done this, go ahead, connect your points, and draw your arrows on both sides. The last way that you can graph is by making a table of x and y values, or inputs and outputs, but that process is far more tedious than the other two that I just showed you. Okay, on the back side here, it says to choose a method to graph the following. State the x and y intercepts for each. So I'm just going to do the first example here. So for the first example, it really doesn't matter which method you choose. I typically like to solve for y and graph in slope-intercept form. So in order to solve for y, I'm going to add x to both sides. That's going to give me y equals x plus 6. For y equals x plus 6, I know that I'm going to have a slope of 1, because 1 is my coefficient on x. And I'm going to have a y-intercept of positive 6, which would be the point 0, 6. So let's go ahead and graph this. 6 is my y-intercept, and I have a slope of 1 over 1. And I'm going to continue this down until I hit both of my axes, because that is a piece of information that I need to state. Okay, from my graph here, my x-intercept would be 2, 3, 4, 5, 6, -6, 0. And my y-intercept is going to be 0, 6. Make sure when you write your x and y-intercept that you write them as ordered pairs. Okay, continuing on the left side. For number 3, this is one of our special cases. So anytime we have x equals or y equals, identify that point on your axes and draw a horizontal or vertical line from there. So x equals 4, at 4, there is our point. And anytime you have x equals, that means that you're going to have a vertical line. Okay, in this case, obviously, my x-intercept is at 4. So I'll write the point 4, 0. And since I have a vertical line, there is no slope. Well, the slope is undefined. So that way, it's never going to cross the y-intercept. So I can just say that there is no y-intercept. Okay, just like usual, try the other two examples on your own and come to class with any questions that you have. Thanks for watching.